fun experiment today. So we have the Anova Precision Cooker 3.0 and the 2.0, if you will, the previous version. And what we want to do is test what the difference between 1100 watts is and 1000 watts is. So we know there aren't that many differences between the 3.0 and the 2.0, the biggest thing being 1100 watts. Well, what does 1100 watts versus 1000 watts really mean? What we got rigged up here is both of these are set to 70 degrees. The water temperature is 70 degrees currently. We have them going up to 185 degrees. I've got temperature probes in both sets of water. They're rigged up exactly the same way. And we're gonna measure how long it takes to get to various degrees. I'm hoping to have some pretty good data behind it, and we can sort of sift through it and look at it and sort of decipher what it all means. But let's get started with the experiment. First of all, I gotta start these at the same exact time, so I'm gonna be careful to do that. I'm checking to make sure they're both at 185, they're both at 185. They both measure 70 degrees. We've got a flame boss here with the probes to graph what happens. So here we go, we're gonna go at the same time. Just a quick check-in around the 100-degree mark. Right now, the Anova 2.0 is at 101, and the Anova 3.0 is at 104.5. So you're starting to see some separation here. We're about a little over 20 minutes in. So from 70 up 30, 35 degrees, you're starting to see a few degrees separation. Quick check-in around the 130 mark. We have the Anova 2.0 at 123.5 and the Anova 3.0 at 131.5. So we got about, an 8-degree difference here, and we are a little over 40 minutes in. So the separation continues. Quick check-in, we are just over an hour in, and the 3.0 is at 150. 2.0 is at 140 and change. So roughly a 10-degree difference, a little over an hour in. As you would guess, continue to diverge a little more as time goes on. But yeah, hopefully you're getting some meat around what it really means to be 100 watts more, and you can judge for yourself if it's a bigger or lesser difference than you would have expected when you just hear, 1100 watt machine versus 1000 watt machine. Be back with more. Guys, we've hit a stall. We're 3.5 hours in. We're stuck at 163.5 for the 2.0 and 172.3 or so for the 3.0. Obviously, when you get to these high temps, it's better to have a cover on to help trap some of that heat. So we're gonna do that right now. Rather than call it quits and say, hey, we hit a stall, just to give you some idea, it's been at these temps for, call it, half an hour or so. So we're gonna put a cover on these rather than call it quits. We'll see if we get to 185. But there's the data point, kind of stall at this 163, 172 level. Again, we'll have a little more analytics as we look at the data, but that's what's happened right here. We're gonna put a cover on both at the same time, see if we can get to 185. It's worth a shot. Let's see what happens. Thanks. Guys, we did it! The 3.0, it hit 185. It's been roughly 15 minutes, or a little more than that, since we put the cover on, so it ran from 172 to 185 in roughly 15 minutes. Cover makes a humongous difference. Remember, we were at 172. We were probably changing 1 degree every half hour or so at that stage, where it had plateaued. So put the cover on, we jumped 13 degrees in 15 minutes or so. So the covers really do help. 3.0 made it to 185. We're waiting on the 2.0. The 2.0 currently is at 175.5 or so. So has continued to lag by about 10 degrees, which we established a couple hours ago now. And it does continue to rise. So I'm confident the 2.0 will get there too. It's a matter of, we're not going to evaporate enough water to hit the min before it, so we'll see how much longer it takes to reach that 185 on the 2.0. But we made it, at least with the 3.0. Guys, you hear that? The flame boss is telling me we're done. Both cookers are up to 185. I'm gonna turn the flame boss off. So after we put the lids on, the 2.0 ramped up real quickly too. So I think it was roughly, I wanna say 10, 12 minutes behind the 3.0 and catching up. So lids make a huge difference, particularly when you're getting up to these high temps. The other thing I noticed was, you might be able to see it here, but there's a considerable amount of evaporation, maybe unsurprisingly, given the high heats we're cooking at, but you lost about an inch of water over the 4 hours that we were cooking here in the 16-liter Anova. So that's a considerable amount of water. But yeah, we made it to 185. We had to adjust a little bit, put the lids on. We'll analyze some of that, the graphs and just some of the data here. So let's get to that. So here we have the graph from the experiment with the 1,000 watt Anova versus the 1,100 watt Anova. So you can see the yellow line represents the 1,000 watt Anova, or the Anova 2.0 if you will, whereas the gray or the black line, the dark line here, represents the 1,100 watt Anova, or the Anova 3.0. The big thing here to see, obviously, no big surprise, the 1,100 watt sort of heats up the water more quickly than the 1,000 watt. Not a surprise at all. Maybe more of the baseline stuff. Here we started to cook at 2:54, nearly 2:55 roughly, 2:55 p.m. And then we sort of finished our cook full 4 hours later. Again, the experiment was to go from 70 degrees room temperature water up to 185. As you guys well know, watching the video, at one point we stalled out, as you can see on the graph, and then put the lid on and quickly ramped up from sort of the plateau of the 170, 160 type range, all the way up to 185, rapidly went ahead and achieved that. But the bigger things that we haven't spoken about yet, I think you can see, they're heating up water at a very similar pace early on till about 10 minutes in. That's when you start to see the divergence. And then, as you get higher in temperature, the larger the distance between the points get to reach that same temperature. But if I were to kind of look at this and look at, temperatures like 130, where you might want to heat a steak to, it took 40 minutes or so for the 1,100 watt to get there. And it took, let's see here, an additional 8 minutes and change longer for the 1,000 watt to get to that 130 number. And as you sort of progress up to something like 150, that's at 402 for the 1,100 watt, and you get there at 417 for the 1,000 watt, so a full 15 minutes later. So definitely started to get wider and wider as you go up the temperature spectrum. Again, the biggest thing here is use a lid. Using a lid is going to help improve your time to temp tremendously. It's not just for evaporation. It will help improve, just keep things more efficient. So that's my biggest takeaway, I think, is if you're using a lid, ultimately there's not going to be a huge difference no matter what temp you're getting to. I think if I were to sort of look through this graph and see what's going on after the lid's on, what's going on before the lid's on, I would estimate that the 1,100 watts is probably going to get you to whatever temperature you want. Of course, this is a generality, but within 8 8 minutes or so, 8 to 10 minutes faster than the 1000 watts. So you can sort of look at that and say, all right, what's that worth to you? Obviously, we haven't talked about, this is all about speed. We haven't talked about, how much more water, 1100 watts could circulate versus 1000 watts, etc. But here you can see, I think the good summary is 8 to 10 minutes longer for the 1000 watt versus the 1100 watt cooker is kind of the key takeaway. So thanks for sticking with us through that little test there. So there was a lot to learn from those graphs. Thank you for watching this. I appreciate you guys. If you like this video, give us a thumbs up. Hopefully you found this interesting. Subscribe to our channel if you did. And thank you. Bye now.